All right, so for this video, we're going to be reviewing everything we've talked about with trig graphs. We've talked about midline, we've talked about amplitude, we've talked about the period, we've talked about maximum, minimum, the phase shift, which is the horizontal left and right, and the vertical shift, which is the up and down, and it also correlates to the midline. So we're just going to review all of this. I've created this little kind of formula sheet or reference sheet for trig graphs. It will be up on Canvas for you to reference, especially when you're doing your Canvas practice. I am going to go over a few of the Delta Math examples as well, just to make sure everybody is clear on how to handle those and how to identify all the key pieces. So when I'm looking at these parts of a trig graph, so the first thing I need to make sure I do is I identify what my values are. So I have my A, my B, my C, and D. So when I'm looking at this, I have my amplitude. Now remember, my amplitude is how far above the midline and how far below the midline my wave goes. So my amplitude is going to be my absolute value of A. Now, why is it the absolute value of A? Well, it's the absolute value of A because it is it's a distance, and we can't have a negative distance. So I would have the absolute value of 5, so my amplitude here is just going to be 5. Now, speaking of midline, my midline is the middle, or what splits my sine or cosine graph in half. Now, my midline can be found by looking at the vertical shift, that value, how far up it's going or how far down it's going. So when I look at this problem, my shift, my midline, is going to be y equals, and my d value, which is going to be positive 3. All right, so then the next thing we're going to talk about is the period. So the period is how far one wave is stretched out or how far one wave is compressed in. So for that period, we do 2 pi divided by d. So 2 pi divided by b. So my 2 pi divided by 3 means that it's going to go from 0 to 2 pi over 3. And I'll show you in Decimus just a second that period. And then finally we have our phase shift. Now remember, our phase shift is the same thing as our horizontal shift, is how far left or right it goes. And when we do that, it's actually going to be the opposite value of C. So if right here in my problem, I have x minus pi, when we pull that out, it's the opposite. So instead of minus, it's actually going to just be positive pi. So that means that we're going to shift over pi units to the right. All right, so I'm going to go to Desmos, and we're going to look at this particular example. So I have y equals -5 sine, and we had 3x minus pi plus 3. Now, let me make sure I typed it correctly. So we have 3x minus pi plus 3, okay? So why do I only see this part? Remember, in one of my videos, I told you that in degree mode, you're going to have to adjust the screen so that it fits between the -360 and 360, because a circle is 360 degrees. So if we actually go to radians, we can actually see this much better. All right, so I'm going to adjust this, and I'm going to look at my example here, or I'm going to screenshot it so we can kind of see our pieces of it. So we said the midline, okay, the midline was at y equals 3. So here's my midline, and that's splitting my waves in half. We said the amplitude here was +5, and we can count from here to here, that's 5 units. We have our phase shift. So remember, a sine graph normally starts at 0. So in order for us to start at 0, we actually shifted pi units to the right. And then we went up by 3 units, okay? So the other thing that we've got to look at is our maximum or minimum. So my maximum value that we're going to have is going to be a maximum. So if we look at all these maximums are at 8, and these minimums are at -2. All right, so just kind of keep that in mind. The other thing that I kind of wanted you to look at was the fact that my one wave here, so if I look at my one wave that I have, so it goes up and we come back. So when we're looking at that one wave, that one shift, that is my 2 pi over 3. Okay, so if I go back to Desmos and 2 pi divided by 3 is going to be approximately 2.09. So if I go back to that 3 value and I look at my x is approximately 2.09 for that 3 value, which is where that one wave actually ended. All right, so just some things to think about. So what we're going to do is we've kind of looked at these pieces. We've talked about how to find the amplitude. We talked about the midline. We talked about the period. So we said our max value was at 8, and our min value was at -3. So we're going to look at our delta math activities, and we're actually going to just make sure we are all on the same page. So if we're trying to find the period, so in this particular problem, it says that they want us to find the period. So remember, period is 2 pi over b. So my b value in this problem is going to be 4. So again, I'm going to screenshot so I can just kind of write. So my b value is 4. So I'm going to do 2 pi over b, which is going to be 2 pi over 4. Well, we need to simplify this because we can't just have that 2 and 4 since they are both divisible by 2. So 2 divided by 2 is going to be 1, so we're just going to have pi, and 4 divided by 2 is going to be 2. Now, you can leave it as pi over 2, or you can write it as 1/2 pi. It's completely up to you, because you should be able to do it either way in Desmos. So, in Delta Math. And then we have our period. And of course, it does give you some explanations in that. All right, so looking at our graphing. So it can be kind of confusing if you don't understand exactly what they're asking you to do. But they're starting this by asking you to kind of label your x and y axis. So the x-axis, you want to label that with your period. So I have 6 as my, so 6 is going to be my b value. Okay, so I'm going to do 2 pi over 6, and that's going to give me pi over 3. So we want to make sure, all right, so when we go to label the x-axis, we're going to hit that pi button, and we're going to put divided by 3. Okay, so what does that do? Well, we're going to do the x-axis 2 with 1, just because 1's going to work for us. And then we're going to hit done. Now, that puts this little point over here, if you can see pi divided by 3. And we have to place 5 points on our graph. Now, remember, when you do a sine graph, you always want to start at 0. Our amplitude is 1, and we want to make sure that we go up to 1, back down to 0, down to 1, and then back up. Now, your graph can look completely different from mine. So 1, and then I put pi divided by 3 here. And as long as my units are evenly sectioned into 4 sections, then I can do it. So I could do 1, I could go up to 2, I could go up to 1 and skip 2 units, skip 2 more and go down to 1, skip 2 more, and then go back up after I skip 2 more. So as long as you are in 4 equal sections, your graph is still going to be right. The only thing that you got to make sure is you got to pull that point over to the very end so that they know that that one wave that you've created, that one cycle, ends at pi over 3. Okay, and then of course it gives you a lot of information here about your amplitude going up to a maximum 1, going down to a minimum 1. And you see that you can see the dashed lines that show that they've sectioned them off. So I'm actually going to just skip right over to a level 4. So looking at this problem for level 4, we've got to identify quite a bit of information. So we know that the midline is going to be at 10. All right, so I'm going to kind of go ahead and go through this. So the midline is going to be at 10. The amplitude that we're going to have is going to be the absolute value of A, which is going to be 8 units. So we know we're going to go 8 units above 10, 8 units below 10. And then we also need the period. We need to know where one wavelength starts and stops. So for the period, we're going to do 4 pi. Well, the formula is 2 pi over B. So we're going to do 2 pi over 4 pi over 5. And remember, we changed that to multiplying by the reciprocal. So we're going to change that to 5 over 4 pi. So technically that's over 1. So we're going to cancel out those x values. And we have 5 times 2, which is going to be 10, divided by 4. And we'll simplify and make that 5 over 2. So we need to make sure our period on my x-axis is 5 over 2. And we need to make sure that we at least go up to 18 units. So we're not going to be able to go by units of 1 because there's not enough tick marks on the y-axis for positive. So we're definitely going to need to make sure we go by units of 2. Now, if you wind up with something bigger than that, then do units of 4. If you have, go up to 40, whatever number you need to go up to, just kind of adjust the scale. So I'm going to adjust that scale. So this is going to be 5 over 2. And I'm going to put this in units of 2. All right. So we have that 5 over 2, and they've adjusted that for me. So remember, my midline is at 10. So 8 units above that is going to be at 18. Now remember, cosine normally starts, the key point starts at 0, 1. But because we're at midline of 10 and then going up to 18, we're going to need to make sure that we start this at 18. All right, so midline, so we're going to make sure we do it in equal sections. So the midline, we're going to go back down to 10. Then we're going to go below 10 by 8 units. So that's going to go to positive 2. We're going to go back up to 10 and then back up to 18. And then, of course, we're going to drag that 5 over 2 to where that last point stopped. Okay. So we have a midline at 10. You can see the midline at 10. If you were to imagine that it's splitting it in half there. We have an amplitude of 8, so we were 8 units above, we went 8 units below, and we did it based off of the key point. Technically for cosine would have been at 0, 1, but because we had an amplitude of 8, we had to start at 0 and 18. So if we look at this, we can see all of our pieces. Now you can see theirs is very different from ours. We did ours, we only did one little section. They split theirs up so that they had 3 tick marks between each section. As long as they're equal sections, it will still count it as correct. Now, I can also look at this in Desmos. All right, so once I graph this, I can see that it does have some similarities. I'm going to zoom out just so we can kind of see everything for our sections. So we can see that it did start at 0 and 18. We said our midline was at y equals 10, which we can see that that does split that wavelength in half. And we can also, we said that the period is stops at that wavelength. So we got 5 over 2, which is the same thing as 2.5. So for one cycle, that's that period. And then we can have our maximum, our minimum. Maximum is going to be at 18. Our minimum is going to be at 2. All right, so let's do one more. So we have this particular problem. And again, we have some key pieces here. So my amplitude is going to be 6. My midline is going to be at -2. And we need to figure out our period. So I have 2 pi divided by 2. So 2 pi divided by 2 is just going to be pi. So when I go to type this in, I'm going to type in pi. And I'm going to just do by units of 1 because we are starting at -2 and we're going up 6 and down 6, which is more than enough room on the graph. All right, so we have our pi point right here that we're going to adjust. So I don't really care how you section off your pieces as long as they are equal sections. So I'm going to start at -2 because -2 is my midline. And remember, cosine, this is going to be flipped over. So we're actually going to go down by 6 units. So if I go down by 6, that's going to put me at -8. And then I'm going to go back to 0. All right, so -8. And then we're going to go back, to -2, because that's where our midline is. Then we're at -2, we're going to go up 6 units. So if we go up 6 units, that's going to put me at +4. Then I'm going to go back down to -2 and then continue. Now, why did I do this upside down? Again, I did this flipped over because my amplitude was a -6. So when it's negative, you're going to flip that value over. And then I'm going to drag my pi over to that last point. And there's my problem. Now, if you had, and you can see that they section theirs off in 3 x value sections. We did it in 2. You could have done it in 1 as long as they're equal sections. Again, you could have put this into Desmos, and you would have seen that it kind of did that flip over. So y equals -6 cosine of 2x minus 2. So we said the midline was at -2. All right, and we can see that it did do that flip. So we started down here at -8. Okay, we went up, back up to -2. We went all the way up to 4, back down to -2, and then we came back to a full cycle at pi, which is exactly what we found our period as. So I hope this helps you as you're going through. Please use your reference sheet, use Desmos, use whatever you need to. Use us, email us, let us know what we need to do to help you guys.